Alright, Year 12. So this lesson is on vector equations. Um, it's going to be a short one because when we're solving vector equations, they're similar to solving real number equations. So if you move it to the other side, you do the opposite operation. One of the key things though is that you can't write a vector as a numerator or denominator. You have to write the scalar product in the front. So for example, if we were to solve this for x, we would have the vector x is equal to a half a. We do not write, and we emphasize this, a over 2. Now, the reason being, one, a over 2 has no meaning in vector algebra. And the reasoning I had for it personally would be, yeah, sure, you can divide the length of the vector by 2, but when you write it like this, it's as if you're saying you're dividing the direction by 2 as well, which doesn't make sense. So you just need to make sure you write it with the fraction in front. Other useful rules, if you've got vector x plus a and that equals to b, then for vector x, it would just be b minus a. So like solving any other equation. Similarly, if kx equals a, where x is a scalar, then x is equal to 1 over k a, right? I'll just put in here where k is a scalar. Okay. I'm sure you can complete these yourselves, but I'll just make sure that we've got the solution down. So if I solve for x, it would be x equals, we move the r over and then divide everything by 3. Put s plus r. Whether we write r plus s or s plus r will give the same answer. So, or you could write it as the expanded form. There is no right or wrong answer for that one. And then for this one, it would be x is equal to a half c minus d, or a half c minus a half d. Straightforward. You can write these vectors in component form using matrices. So you'll see in your GDC you've got the square brackets. Those would be synonymous with the round brackets. It's just two different forms. It's like if I put a bracket around bed, it's the same as if I write bed. Like it's the same thing. The key thing about this though is you can actually store a vector to a name of it. So say form 1 is vector p, I will store that using the variable key, which is next to the delete key. And that means you don't have to type out the vector every single time you want to use it. From now on, if you wanted to calculate a half p, you can just type a half times the letter p and it will give you the answer. However, you need to make sure before you store things that you actually clear your variables that you might have previously saved in there. So if you've never done this with a calculator, you might have p and q saved in there as like 2 and 5 from like year 8 or year 10. So it's important before you do this that you clear everything in your calculator. It also is able to calculate the modulus, so the length of the vector. So we've stored p and q here already. If we go into your calculator to menu 7 matrix and then 7 norms, you can find the length, the modulus of vector p or q. You already completed C, D, and E, I think, today in class. So I'm just going to keep going so that you have another exercise to do because that's kind of straightforward. Wasn't very strenuous. When we go into vectors in coordinate geometry, this is where it gets fun because you actually get to compute things and calculate things and solve problems. So we're going to link vectors with coordinate geometry. So this part's pretty cool. If I assign point A as A1 and A2, so that's my X and Y coordinate, and B as B1, comma, B2. So it's like when you used to use X1, Y1, X2, Y2. Instead, we're linking the coordinates with the actual point's name. This will come in handy because then you'll see the pattern of how we actually write the vector in component form. So if I would just note that with a x and y, we always do it relative to the origin. So if this was 3, 4, that's saying it's 3 units horizontally away from the origin and 4 units up from the origin, right? So that's all relative to 0. We'll come back to that note. So if I wanted 0a, OA, as that vector, and then I also draw in this part, I might use a line. I know that's a bit hard to see, but bear with me. Those two. Then to get vector AB, you could say it's negative OA plus OB in vector addition, and that gives me AB, right? So vector negative OA, though, we can write it as A1, A2, and OB is B1, B2, because that's how far they are from the origin. So that vector would be B1, B2. That is AB, right? Now that will equal to, adding these vectors together, negative A1 plus B1, but instead of writing that, I would write B1 minus A1, B2 minus A2, so that we have the positives first. That means to get just vector AB, you don't always have to break it up into the vector OA and OB. You could just take the second letter's coordinate minus the first letter's coordinate. And I know from calculating gradient that you're used to taking the y's first. Just note that in the vector form, we are putting the x's first, the horizontal component first, and then the vertical one. So the second letter is B, so it will be B1 minus A1, B2 minus A2. We'll have some examples here. So for vector OA, A is second, so you're going to take XA minus 0, XA, and YA minus 0, which is YA. Okay? For these ones, B from O, as in find the position vector of B from O. So B from O is vector OB. It's saying O comes first and then B. And that would be 3 minus 0, 3, and then 4 minus 0. So that's part A. Part B, B from C, that's A, B, which is 3 minus negative 1, 3, I'll write it properly, 3 minus negative 1, and 4 minus 2, which is 4, 2. Okay? And then for part C, vector CA, that would be CA, 4 take negative 1, which is 5, negative 5 take 2, negative 7. I think you get the hang of it now. Now, this question is an interesting one. AB is the diameter of a circle with center C, which is that negative 1, 2. If B is 3, 1, find BC. So they're asking for this vector along here. BC would be C's second, so negative 1 minus 3, and 2 take 1, which is negative 4, 1. That's the vector. Now the coordinates of A. Well, we know that because that's a diameter, this would be the same vector over here as well, because they're both the radii. So the vector here would be the vector here. Now this we're going to let vector point A be A1, A2. That means that CA is equal to A1 minus 1, which is plus 1, A2 minus 2. That vector should be the same as vector BC, which we found in the previous part as 1, negative 4 and 1. So A1 plus 1, A2 minus 2 is negative 4, 1. That means that A1 must be 3 and A2 must be 3 as well. Sorry, A1 would be negative 5 because negative 5 plus 1 is negative 4. Which means that A has coordinates. I don't think it likes that, I've got so many lines. Negative 5, 3. So you might remember or have seen this before. That's the congruent sign, and when we're labeling a coordinate, we're allowed to say that A is this coordinate. So we don't use the equal, you can use the congruent sign. The next part is on distance. You know that when we're talking about the distance or the length of a vector, we use the absolute value sign. So here in vectors, it's actually called the modulus. That's like the distance, the length of the vector, the distance between A and B, etc. So if we've got P is negative 1, 2, and Q is 3, 1, find vector PQ, that would be 3 minus negative 1 and 1 minus 2, which is 4 minus 1. So the modulus, or the distance between PQ then, would be 4 squared plus negative 1 squared, which you probably remember doing previously. So that would be root 17. And that you would remember this then as your distance formula as well. So it's all linking together. This second part, vector equalities, you know that vector AB would be the same as vector CD if and only if, and we write if and only if as IFF as well in maths, and that's like an official way of writing if and only if. P equals R and S equals Q. So if this length and this length are the same and this are the same, then there's no way that these two vectors can't be the same or equal. For this example, it's asking you to find the coordinates of C and D. So they only gave you A and B though. However, they've shown you that they're equidistant, which means that this vector would be the same as this vector, which is the same as this vector. So for vector AB, that would be negative 1 plus 2 minus 2 plus 5, which is 1, 3, right? Then BC, let's say C is C1, C2, would be also 1, 3, and if we work it out using C1 and C2, would be this. That means C1 must be 0 in order for these two numbers to be equal, and C2 must be 1 in order for them to be equal. Therefore, C has coordinates 0, 1. Now, the last one, in a similar way, CD would also be vector 1, 3, and D1 minus 0 be D2 minus 1, because now we're finding the distance